Hello, everyone, and welcome to another edition of Let's Talk ETC. I have a very special guest, Markus Kuppe, who I've been wanting to chat with for a long time. He's an expert on some very important technology that I think will be very eye-opening, namely TLA plus. And I think everybody should be familiar with the promise and potential of TLA plus. So welcome, Markus.
Yeah. Hey, thanks for having me.
So I know you're busy, and so thank you again for chatting with me. And why don't you start by just kind of giving a little introduction to how you got involved with TLA Plus and kind of what you're doing with it?
Oh, so my involvement with TLA Plus goes back to 2011, where I joined the project to primarily work on the tooling, the development environment, and that one gets to work on TLA Plus. And over the years, my exposure has been deepened, and now I'm pretty much responsible for the tool that gets used to model check TLA Plus specifications.
Okay.
And this toolbox.
Okay, good. Now, so the reason that I was so interested in chatting with you is so a lot of people, of course, want their software to be secure, and then they know that the gold standard is to mathematically prove that your software is secure, which people then get frustrated because that seems impossible or impractical in the extreme. And then TLA Plus seemed like something that was very practical and almost magical in how useful it was. So can you give us an introduction to why anybody should care about TLA Plus?
So I think there is distinction to be made here. So you have these program verification tools where you can prove your implementation to be correct, or you can check your implementation to be correct. On the lower end of the scale, I would say that just unit tests, right, that everybody uses.
Right.
And on the other end of the extreme is where you use some Ethereum prover to reason about your implementation, and you actually know why it's correct, and you prove that this reasoning is correct. That's for program code verification. TLA Plus kind of tries to show that your ideas are correct before you set out to come up with an actual implementation. So it works in addition to program verification, but it makes sure that the stuff that you try to prove correct on a code level later on actually works from the design's perspective. And so it helps you to catch the really difficult problems early on in the game before you spend enormous amount of time on the actual implementation. And this comes because it uses basic mathematics. So it's a high-level specification language. It doesn't constrain you by imposing certain programming languages constructs on you, or makes you depend on some framework or technology. You really have the full expressiveness of mathematics, and therefore you can make rapid progress in expressing your ideas, and then use the verification tools that come with TLA Plus to verify your ideas at a high level. And then in the next step, in the next phase of the development process, you would maybe also use tools to verify the actual implementation.
Right.
But the assumption generally here is that you will catch a lot less bugs or run into a lot less bugs if you've done your homework, so to speak, in verifying your design.
Right. Now, I think, at least me personally, maybe other people as well, but people get so focused on the code that they don't realize the importance of getting the specification correct. And tell me if this is, I like to make things simple. Tell me if this is a good analogy of the problem with not having a good specification. So imagine that in the future there was a artificial intelligence self-driving car, and we told it, okay, I want you to take me to the store as fast as possible. And the car might think, okay, if I kill you, but if I get you there faster by killing you, that's okay. Well, no, that's not what I meant. What I meant was get me there, safely. But then the car could say, oh, okay, is it okay if I go off-roading or do something dangerous that damages the car? And then, no, I didn't mean to damage the car or hurt me. And then it goes, okay, is it okay if I harm a pedestrian? And you have this conversation where you thought that it was clear what you meant, but there's all these ambiguities.
Yeah. Yeah, I guess there's a saying, right, that writing is nature's way of telling you how sloppy your thinking is. And I think this is one of the basic ideas behind TLA Plus, that you get forced to express what you actually want in writing. And that's maybe the first step. And the next step, you also express it mathematically, because usually what you do is you come up with prose first in your TLA Plus specification, and then you formalize it more into math. So first step is to express your ideas in writing, and then you describe or you run through the process that you just described, that you find out, oh yeah, this is all not as clear as I thought it is. And then the next step, even formalizing it more into math, shows you additional errors in your thinking. And maybe here's a case study where the Xbox 330 people that worked on it a decade or so ago, had this release coming up, wanted to do a Christmas launch, and a Microsoft Research summer intern, just specified IBM's memory coherence protocol from all the kind of documentation he could get, probably from some kind of prose specifications. And just writing this particular TLA Plus specification revealed a very subtle bug. So they went back to discuss this with the IBM engineers. And first of all, they said, oh, no, that's not possible. And only after several weeks, they acknowledged that it's a problem, that it wouldn't have been found with their regression testing, and that the outcome of this bug was that every Xbox would have deadlocked after 4 hours of use.
Wow.
And there was no tool involved that formally verified the specification. Just by writing down the prose specification in TLA Plus revealed this kind of bug.
Right. And so, so there's the evidence is irrefutable that TLA Plus has a lot of potential, right? Not just Microsoft, but in my research, I found that Amazon has used it to great effect, Intel, right?
Yeah.
A lot of these big players have found subtle bugs. And so you really can't argue with the evidence, I don't think.
Yeah, I think the problem always is to put a price tag on finding a bug early, the benefits that it gives you in terms of numbers. It's hard to quantify this empirically, how well it pays off to invest in TLA Plus, especially on a scale that is that we see at Intel or Amazon, where you have large teams, where you have dedicated verification engineers. But it doesn't have to be, TLA Plus doesn't have to be deployed in such a formal environment. What we also always see is that it's more nimble use, in the sense that here's an engineer from a less known company who gets the feeling that the design that they're currently working on for some system starts to be too complex. So you keep working on your whiteboard, and everybody tries to keep the ideas together, but they feel that they struggle. So somebody just picks TLA Plus, specifies an aspect maybe only of this design in TLA Plus, and then they verify it, or he or she verifies it, and immediately they know that they've made an important step here, because now there's something fixed,
right,
from which they can continue on.
Yeah. Now, also TLA Plus has a good pedigree, right? It was developed by Leslie Lamport, I believe, the creator of LaTeX and the Turing Award winner. So it has good credentials also.
Oh, yeah, sure. Leslie, before he worked on TLA Plus, he obviously was involved with distributed systems and concurrent systems for several decades. The bakery algorithm, for example, is a very prominent example, or the Paxos consensus algorithm. So these are highly complex, difficult to reason about systems, especially distributed systems. And out of this work came Leslie's work on formal systems, which eventually ended in TLA plus.
Right. Now, why is it called TLA plus? Is it temporal logic something? What was it?
Yeah, so the A stands for temporal logic it's temporal logic of actions, and the plus is because it's an extended version, so to speak. So there's TLA, and then there's TLA plus. But that's just more of an academic distinction. For the regular user, it's TLA plus. And the A is kind of important because back in the days when Leslie Lamport worked on this, most people would use temporal logic to describe the system and then also to reason about the system. And he found that this was very inefficient. It was hard to express a system just in temporal logic. And also it was difficult because there was the actual actions that a state machine would take were missing in the logic. So you couldn't express the actions. And that's one of the major contributions of TLA plus, that introduces the notion of actions into the logic on which you can reason about.
Okay. Now, in my research, and you also confirmed it, that Leslie was interested and focused on concurrent complex systems. Does that mean that TLA plus it's still useful for systems that don't have several processes, several threads, right?
Yeah. So that's actually something I like to stress about. Just recently, I saw a TLA Plus related talk on YouTube, and the person motivated it by showing the most difficult systems one can think of, for example, a nuclear power plant, a fighter jet, or something like that. You obviously need very good tools to design the software for a nuclear power plant. I hope at least people do so. But TLA Plus is also useful for just your sequential little algorithm you want to specify here. I personally specified in recent days, specified a tiny algorithm to generate a set of numbers in a certain order. I wanted it to be efficient, and that's no concurrency going on, no distribution here. It's just your tiny little sequential algorithm. And that can still be expressed in TLA plus, easily be expressed in TLA plus, and then in the next step, verified by the tools. And translating this TLA plus specification then into code becomes really easy.
Mm-hmm. Yep. Yeah. Now, another question I wanted to ask, some people listening might be thinking, that it's very difficult to get to learn TLA plus, but I was happy that I read some Amazon testimonials, and they said some engineers, even just playing around with TLA plus on a few weekends, were able to pick it up and make good use of it. So it doesn't sound like it's that difficult to pick up. Would you agree with that?
I guess I'm most qualified person to have here an objective, have objective judgment. But at any rate, what we usually see is there is this dialect of TLA plus, which is called Pascal, that looks more like pseudocode, imperative pseudocode that you get if you, for example, use the LaTeX algorithms package. Uh-huh. So it's very close to C code, for example. It even has a C style. And that's easier for people who have been brainwashed by years of C++ programming to get started with TLA+. Picking up the syntax getting used to the tools doesn't take longer compared to any other programming language or tool that you want to use. So you will get some kind of benefit out of it pretty quickly. In the long run, I guess what will happen is it will change your thinking. I don't know if it's inside the Amazon paper that they published on their use of TLA plus, but one of the authors said that TLA plus is the single most valuable thing that he learned in his career, and it has made or changed the way how he thinks about complex ideas, complex systems. It has given him the means to express his thoughts in his work. So that's something that comes out at the end of longer exposure to TLA plus. But at the beginning, it's very lightweight to get started with. I would say.
Go ahead. No, I didn't mean to interrupt. Go ahead and finish what you're saying.
No, go ahead.
Okay. No, I have to be honest. You started to answer that question slowly, so I was afraid that you were going to say that you disagreed with the Amazon engineer, that it was really difficult. But I'm glad that you gave a careful answer, that it is easy to pick up, and then it has a lot of benefit afterwards. So that's good to know.
Maybe to add, most program verification tools that I know of are usually just used by people who have an advanced degree, who really get focused on this kind of work, who specialize in this kind of work. And TLA plus, on the other hand, I think on the internet, on some Reddit discussion, has been called formal verification for the working man. In recent years, we have seen a lot of adoption within the engineering community, not so much so TLA plus usage goes back for several years now in the academic community. But the increase in usage in the engineering community actually shows how much value it provides, and that it's actually possible to get some results out of it within a reasonable amount of time compared to program verification tools, prover languages that take a long time to master.
Right. No, that's really encouraging. I love that. TLA plus is formal verification for the working man. Is that what you said?
Yeah, it's not me who said it, but somebody on the internet. Yeah.
Yeah. No, I thought that in order for these kind of tools to become widespread and really benefit humanity, they had to become more user-friendly and more approachable. So it sounds like TLA plus is a step in that direction. So that's good. Okay.
Maybe just one more thing to be fair. So to one extreme, I was talking about program verification with a proof manager when I referred to these more complex, harder to master systems. And TLA plus also has a proof extension where you can write proofs, but especially in the engineering domain, we see that most users are satisfied by using the model checker that checks the finite model of your specification and doesn't require as much work to get this verified compared to a proof manager.
Okay. Now, also it's very approachable. One thought that I had was, have you ever heard of the 20-80 principle? That sometimes if you have a list of things to do, 20% can give you 80% of the benefit. TLA plus seems like it's that 20%. If you only had a finite amount of resources, it really gives you the most return for your investment.
Exactly. I think this kind of maps to the thing with the model checker and the proof manager that I just talked about. So what you usually do is you write a specification and then you use the model checker to check the hell out of your specification for a finite model, usually a very small model, but you catch many bugs that way already. And then, you probably spend 80% of the time on getting the last 20% right by using the proof manager.
Right. Right. Now,
for engineering teams, it's usually sufficient to just, it's not for engineering sufficient to get 80% of the work correct. So it might not be 20/80, but more like 99 and 1% here in terms of correctness. So the model checker turns out to be very powerful when it comes to finding bugs, even in small kind of settings. And the proof, doing a proof, correctness proof, is a lot more work because you have to know why your specification, why your design is correct. And with the model checker, will just tell you it's correct for this particular parameters here. So you have to know why it's correct with a proof manager. And that's a lot harder. And I guess most of the time, engineers don't really know why the design is correct. They just know that it works, that it satisfies the invariance of this that they've stated. But that's it.
Yeah. Okay. Can you repeat the name of that tool you said for people that have been brainwashed by years of C programming? Was it PlusCal? Or what?
So PlusCal is this dialect of TLA plus.
Okay.
Which looks more like a C imperative programming language. So you have control structures, while loops, go-to statements. I guess some people will frown on go-to statements, but in specifications, which are usually a lot smaller compared to a program, it's fine to use go-to statements. It's not that big a deal. Mm-hmm. So it's an easier bridge. And when you write pure TLA, you get get some more expressiveness out of it, but it's a different style to write a specification compared to, so it doesn't look as like a program anymore. You just have a bunch of actions and some invariants and operators, and it's becomes more difficult to match this to the specification at the to the code at the end.
All right. So that's PlusCal, PLUSCAL.
Yeah, that's also part of tools when you download it's called the toolbox. So that's our IDE or integrated specification environment. It's probably the better title, which bundles the model checker. It also, you have to manually download the proof manager, but it also integrates the proof manager. And then you get to choose if you want to use PlusCal or TLA plus. So you don't have to download separate stuff, install separate tools. It's just a matter of how you get started.
Okay. Now, one question somebody might have also is, so certainly I think we've made the case that verifying the design is extremely important. That somebody's going to think that, well, there's always still the danger that the software that their implementation of the design can still have bugs in it, right? So we're not 100% guaranteed that everything is going to be wonderful. Can you say something about that? How much of a concern that is?
Well, what we can always do in TLA Plus is to come up with a so-called refinement mapping, where you have a very high-level specification, then you have a lower-level specification, and you map those or match those two specifications by the so-called refinement mapping. And you can keep going, right, until you come to the very low-level details of your system, and even go to the silicon if you want to. I don't think anybody is doing that. At some point, obviously, it makes more sense from an engineering effort to just go to the actual implementation and then write it out in C or Java or whatever language you like. And it's certainly possible to make mistakes here. And I've ran into problems when I manually converted my specifications into an implementation. But usually I find that those kinds of problem can be addressed with the traditional software engineering best practices like code reviews and so on.
Okay. So unit tests, code review, peer review, all the generic standard tools people already use will most likely be sufficient to catch implementation bugs.
Yeah, and implementation bugs are usually not those bugs that you specify in your high-level specification. What you have to remember is that if you write a specification of a distributed system, it might just be 200 or as an extreme 2,000 lines long. And the code that actually executes later on in a data center, that's hundreds of thousands of lines of code. Because the implementation or the specification, because of the abstract concepts and the expressiveness of the math, is so much more concise to the implementation that there is some kind of gap here.
Right. But it sounds like what you were saying was you could slowly, in steps, you could make more and more elaborate specifications that gets closer and closer to Python or C or Java. Is that correct?
That is correct, yes.
And so,
and there is also a team working on a translator from Pascal to Go. At least, within the academic environment. And the hopes are that eventually they will come out with a push-button solution that takes your Pascal specification and then spits out a bunch of Go statements and files. It seems really hard because of the expressiveness of TLA Plus and Pascal and the high level at which you reason about your ideas and your design, and mapping that down to an efficient implementation seems to be a challenge.
Yeah, that you picked up on what I was getting at, or what I was thinking was, yeah, like if it's possible, maybe now or in the future, to automatically generate the implementation.
That would certainly be desirable because it would remove one potential area of failure. But yeah, it seems hard to capture the expressiveness of a high-level specification in a very specific implementation and doing it efficiently so that the code that comes out of it runs as fast as it has to.
Right. Right. Can I see a different question? Are you familiar with the K framework project?
Just very, very little exposure to it. I think I read about it, but that's about it. Yeah.
So what they seem to be doing is, so the same way that you have Flex and Bison or Yak to that automates parser generation, tokenizers. So they take it to the next level, and they want the entire language to be automated. So you specify your intentions, and it automatically creates an implementation of your language. And they've found lots of subtle bugs in virtual machines and in different smart contract languages. So anyways, it sounds similar. It seems like they have the same mindset, right? The idea that you have to, you brutally specify your intentions, the specifications, and that solves a lot of problems. So yeah. And I assume that the reason that they're able to automate the implementation, the creation of the implementation, is because they're focused on this very narrow use case, right, of implementing languages, whereas TLA Plus is more of a general tool for lots more problems, right? Okay. And so if maybe for very specific problems, maybe somebody could create an automatic generation or software generation component for a very specific type of use case for TLA Plus.
Yeah, sure. First of all, you could obviously remove some of the expressiveness of TLA Plus. That would make a translator more easily done. But what you could obviously also do is come up with some specific domain, create a subset out of TLA Plus for a specific domain language and then restrict the use of TLA plus that way to make it easier to generate code.
Okay. Oh, another odd question, if I may. You said that TLA plus changes the way you think, and in a good way, right? So that kind of reminds me of functional programming. A lot of people, they have it on their to-do list, like me, to one day learn Haskell and functional programming, and that apparently also changes the way you think. Is there some similarity between both of those?
Well, I guess Haskell and functional programming trains you to think more mathematically, and the same is true about TLA plus, that it makes you think about the mathematical concepts that sit behind your vague ideas. Especially, it removes this procedural thinking, trains you to unlearn this procedural thinking that years of C and Java programming train you to do, where you initially think about how it's done rather than to think about what you want to do.
Yes, I like that. People get stuck on how it's done instead of what they're trying to do. That's beautiful. I like that comment. Yes. Yeah. Okay. So Kent, as we come kind of to the end, what do you think? Can you kind of talk about what you think is going to happen in the next 5-10 years for the future of TLA plus? From what you said, it sounds like this might be, maybe there'll be a revolution. Maybe it'll become so user friendly that all kinds of software shops will start using it. What do you think for the future?
Well, that certainly sounds great if everybody would start using it. So in the past several years, we've focused on making the engineering community happy, exposing it to the engineering community, also optimizing the tools and the toolbox. One of our goals is to get TLA plus to be taught at universities, so that new computer scientists and engineers that come out of the universities already start working in their particular jobs with this kind of thinking that TLA plus teaches you. And then it's not our highest priority that those people use TLA plus, as long as they have learned the mechanisms to structurally and mathematically think about the work that they want to do to produce in the end just better software.
Right. Good. Now, is this analogy also applicable? So apparently, I'm told that when people started to use assemblers, there was some pushback and resistance because it was a little bit more high level than ones and zeros. And then when people started to use Fortran and other high level languages, there was resistance because it was high level, and people felt like they were losing control of. And then every time you go up to a higher level, it seems like every generation has resistance to that. And do you think that TLA plus and similar tools is like the natural next step, and there's going to be resistance, but it's the inevitable logical next step to improve software engineering?
Yeah, I think that might be, to some extent, is definitely an interesting thought, especially if you think about program synthesis, where you automatically generate an implementation. And in order to generate an implementation, the generator, I'm now talking machine learning here, the generator really requires a precise specification at a higher level of what it's supposed to synthesize, right?
Right.
So in that respect, if we think about program synthesis, high-level specification languages will become a requirement rather than just a very handy tool.
Right. So maybe K framework and then, like you said, you could make TLA plus automatically generate code for specific use cases. Maybe those will kind of increase. And so I like that. So then maybe, yeah, design specification might become more important in the future. And okay, good. Did I forget anything, or is there anything else you want to add? I think you've given us a pretty good introduction to TLA plus, but anything else you want to tell people that might be interested now?
I guess, yeah, if I've managed to spark some interest in TLA plus, I will just use this opportunity here to advertise our TLA plus conference later this year as part of Strange Loop.
Okay.
That's going on in St. Louis. So we will have a full day pre-conference day of TLA plus where we'll especially focus of industrial use of TLA plus.
Okay, so then if the people that are really interested, they could go there and talk to TLA plus subject matter experts and really get a lot of good discussions going.
Exactly.
Yes. Okay, wonderful. Well, thank you again, Markus. And I think it's been very enlightening, and I wish you luck and success on all your TLA plus efforts.
Yeah, thanks. Thanks again for having me.
All right, thanks. Bye-bye.
Bye.